Hi, everybody. We're going to do V.6, which is from the IXL Algebra1. It's multiplication and division with exponents, so it's a combination of the two. I haven't previewed it, so it'll be a surprise like usual. So here we go. Let's take a look and see what they got for us. Remember, the big thing is if we have negative exponents, we're going to move them across the division line and change the sign of the exponent. This is by far and away the easiest way to deal with this. So I have an s to the -8. In case you can't see it, it's in the numerator. And what I'm going to do is I'm going to move that s to the -8, pen here, to the denominator and change its sign. I'm also going to change the s to the -7 to the numerator and change its sign. So what I end up with is s to the 7th times s to the 5th. I moved this 7 to the numerator from the denominator. It was s to the -7 in the denominator. And I have an s to the 8th that I moved from the numerator down. This is by far and away the easiest way to deal with this. A lot of people are going to insist on following the rules of the exponents, and they're going to subtract exponents when they divide, and they're going to add exponents when they multiply. Now, I'm going to show you why that causes problems, but I'm going to go ahead and do it this way, which gives me s to the 12th over s to the 8th, which of course is s to the 4th, because 8 of these s's simplify with 8 of these s's and leave me with s to the 4th. That's why we subtract exponents. Now, I'm going to go ahead and do it the other way as well, just to show you the difference in how they compare. S to the -8. Now, I could just turn off my brain and just follow the rules. And I have an s to the -7 in the denominator. Now, the rules say if I am multiplying equal bases with exponents, I'm going to add those exponents together. So what I'm going to do is I'm going to add this 5 with this -8, and I'm going to get s to the -3 in the numerator, and I'm going to have s to the -7 in the denominator. Now, of course, if you make integer errors, which a lot of people do, this is going to be a problem for you. Now, the second thing it says, if I'm dividing equal bases, it has to be equal bases. Remember, if I have an x over an s, there's no dividing it. I'm going to subtract my exponents. So I'm looking at s, and I'm going to subtract the -3 and subtract a -7. I cannot tell you how many times people make errors due to this sign change right here. That double negative there means +7. So we're really looking at s to the -3 plus 7, which is s to the 4th. This one, unfortunately, a lot of people are going to insist on memorizing the rules of exponents, not actually following what's happening with them. I think that the top version is better, but it is, of course, up to you. I'm going to go with, of course, the right answer, s raised to the 4th. And of course, you could do both. That would be another possibility. All right. Now, in this particular case, I don't need to move it. I could do the addition of the integers in the numerator, which is 11 plus -8, which is r to the 3rd. Now, it seems like I'm saying the exact opposite of what I said last time. The difference is that this one doesn't have any fractions involved. So I'm just going to add these. I added the 2 and the 9. This was r squared times r to the 9th over here, if you can't see it. That gives me r to the 11th. And adding those exponents isn't a problem. I get r to the 3rd. Another way of thinking about it, of course, is to move this r to the 8th to the denominator and divide it. There it is, r raised to the 3rd. Not that difficult. Let's see what the next one says. Now, this one is interesting. Remember that we can only use positive exponents to express our answer. Well, we're supposed to add the exponents when we multiply. And I've got y to the -3 times y to the -9 times y to the -6. And if I add all those exponents together, I get y to the -18. -3 and -6 is -9, and there's two of those, so I have -18, which of course is 1 over y to the 18th power. And there's my answer. Notice I moved it across the division line and changed its sign. So there's my fraction, 1 over y raised to the 18th power. And we have to use positive exponents in these. There we are. All right. Okay, I'm going to go ahead and move it. I know I could do the division and the multiplication and add the exponents and divide them and so on, and you're welcome to do that. If I add those together, I get j to the -5, and dividing by j to the -4 gives me j to the -1, and I end up moving it, and yada, yada, yada. I prefer to just go ahead and move them. So I have j to the 3rd, and I had a j to the -4. In case you can't read it, that's what that says. So I'm going to move it to the numerator and make it j to the +4. I'm going to move my j to the -8, which is right here, to the denominator, which is j to the 8th power. And I end up with j to the 7th over j to the 8th. And 7 of these cancel with 7 of these to give me 1 over j. Again, it's up to you how you do this, and there are more than one way to do these. A good idea, if it's a really complicated expression, is to do it two ways and make sure you get the same answer both ways. So there you have it, 1 over j. I could put the 1 on it if I wanted to, but it's not necessary, of course. All right, we have, I'm going to go ahead and write it so you can see it, -9 s to the -1 times s. Notice that these are conjugates of one another. S to the -1 is 1 over s. We also call them reciprocals. And this is s. And of course, if you add those together, you get s to the 0 or 1. And that's a possibility. A million ways to do this. It really doesn't matter. I actually prefer to go ahead and move these guys to the denominator and multiply them at the same time. So I'm looking at s to the 10th. And that, of course, is 1 over s to the 9th. However you want to do it. I can think of 3 or 4 ways that I could do this, and they'd all be correct. And I'd still get the same answer. So it's totally up to you. That is 1 over s raised to the 9th. And again, we always want to have positive exponents when we're doing these. Darn it, there it is. I know I'm saying there's several ways to do it, and I'm telling you to do it more than one way. Let me make this real simple. You see that g to the negative, well, you may not be able to see it. I've got a g to the 7th, and then I have a g to the -1 times g. Now, that g right there actually has a 1 on it. And instead of thinking of this as g to the 0, I'm just going to simply think of this as that's 1, because they're reciprocals of one another. Of course, if you want, you can think of it as g to the 0 in the denominator, which of course is equal to 1. Remember, anything to the 0 power is 1. So I end up with g to the 7th. You could, of course, move the other g to the numerator, and that would give you g to the 8th over g, which is g to the 7th. So however you like to think of it. I would not even have bothered with any of that. I would have just simply realized that those cancel each other out and just written the g to the 7th. A 1-second problem. All right, that s to the 0 is ignored because remember, anything to the 0 power has no value. Well, it doesn't change anything. It is the number 1. This means 1. It doesn't do anything for multiplication. That's why 1 is called the identity for multiplication, just like 0 is the identity for addition. If you really think about it, you might see how those identities are related to one another because of the multiplication rule for exponents. Anyway, there it is, s to the 60th, and I'm multiplying by s. I know what they're doing here. What they want to do is they want to make sure that you understand that this is not the same thing as this. And of course, a lot of people, when they don't see anything, they think it's a 0, but it's actually a 1 right there, which of course is s to the 61 power, or 61st power is the way to say that. All right, more than you wanted. Let's speed it up just a bit. All right, I'm going to go ahead and move that s to the 8th to the numerator, which gives me s to the 9th. If you can't see it, that's a -7 and a -1. So I have s, and there's a 1 in the numerator here. So I've got s to the 8th in the numerator, s to the 44th in the denominator, and of course I'm going to cancel 8 of these with 8 of these to give me s to the 36. Like I said, lots and lots of ways of dealing with this. You could add the exponents and then do the division. You could, there's, like I said, lots of ways to go. 1 over s raised to the 36. Looks good. Oh no, what did I do? Did I forget one of them? Oh, s to the 9th. Oh my God. I'm such a spaz. Did you see what I did? I said that this one, which you hopefully can see, I don't know, I forgot to write the s to the 9th in the numerator. That's what I get for talking too much. Okay, I'm going to do them right from now on. Sorry about that. All right, I'm going to stop messing around. Enough of this messing around. I'm going to move my v to the -63 to the denominator and add my exponents at the same time. So I'm going to have v over v to the 71st power. I'm going to multiply those v to the 63rd in the denominator. And of course, that's 1 over v to the 70. There it is. Silly, silly man. All right. The s to the 0 is just 1. Lots of negative exponents here. And I'm just going to go ahead and write these two is really s to the 28th in the numerator. And I have an s to the 3rd in the denominator, which gives me s to the 25th. And I'm running on I'm really using a lot of time here. It looks like they're not going to change up the difficulty much. In the past, I've had combinations of variables. Now, if they combine different variables, it might get a little more interesting, but it doesn't look like they're going to do that. But I'll give it a few more minutes. Notice that c to the 0 is just 1, and then I have a c squared, which gives me c to the 5th is my answer. Normally, I would go ahead and go all the way to mastery, but if they don't give me any more variables, then I'm probably not going to do it. All right, I'm going to do two things at once. I'm going to go ahead and ignore the w to the 0, which is 1. I'm going to move the w to the 71st to the numerator and the w to the 77th to the denominator. So what I end up with is w times w to the 71 over w to the 77. Now, I normally wouldn't do this. I just wanted to show you what I'm doing. I would normally have done this as well at the same time and gotten my w to the 6th. And then, of course, that's 1 over w to the 5th. I'm hoping I can get some more combinations of variables, but if they don't, that's okay. Yeah, it looks like they're going to stick with the same. We call that the base. That u is the base in each one of these. So notice that I've just got ones right here and right there. Those are u to the 0. And then I have u squared over u, which is just u. Looks like they're going to actually get easier. All right, let's see what the next one says. Oh, I did get a combination. Okay. Now, when you get a combination of variables like this, you need to deal with them separately, and it can be a real problem. Notice that I've got a u to the -1, and I've got a u to the 1. They cancel each other out. And the v to the 0 I can ignore. Now, I've got a u squared that goes in the denominator because it's a -2. And I have a v to the 4th in the numerator because there's a 1 on that v. So there it is. Now be careful. A lot of people will go, oh, wait, maybe I'm supposed to do UV to the -2 or UV to the second or something like that. Remember, you only operate on exponents when the bases are the same. So in this case, since the V and the U are different bases, I just have the V raised to the 4th. Oh man, look what I did. I need the fraction first. I'll get the fraction first. I have V raised to the 4th in the numerator, and I have U squared in the denominator. And let me just double check this just really quick. The U's cancel, the V's cancel. I've got V to the 4th over U squared, yep. I like to do these type in my head, but I'm trying to write them out for you so you can see what I'm up to. There we go. Okay, at least we got a combination. Now we're talking. Okay, now a lot of people look at this and go, oh my God, what do we do? Well, don't worry, it's not that bad. What I'm gonna do is I'm gonna move all my negative exponents and variables, and I'm maybe gonna combine a few of them at the same time. Now notice that I've got a t to the -8 in the denominator, in case you're looking at this. This is t to the -7. I'll indicate them with my little thing here, t to the -8, which actually goes in the numerator, t to the 8th. Now I've taken care of those, so I can ignore them from now on. Now I also have a u to the -4, but that I have a u to the -1 and a u to the -3, which gives me u to the 4th in the numerator. Now I also have a w to the -1 and a w to the 0, which just gives me a w in the numerator. And finally, I have a v squared in the denominator. I have a v here and a v there. Now I've done all the denominators at this point. Now I'm going to start dealing with the numerators. Now you'll notice I have a u to the -1 in the numerator. So I'm going to move it to the bottom, u to the 1, if you like. I have a v to the 3rd in the numerator. So it's v to the -3, excuse me. And I moved it to the denominator. I also have a w to the 3rd, and I also have a t. Now I've dealt with everything at this point. Now I just put things together. I've got a t to the 9th right there. I've got a u to the 4th, and I've got a w to the 4th. Now it's very common to write these in alphabetical order. It's not necessary, but it just makes things easier. Now in the denominator, I've got a u, and I have a v to the 5th. Well, the only things that cancel is the u and the u to the 4th, which gives me u to the 3rd. So I'm done. I've got s, t, u, v, w, yep, and they're in alphabetical order. T to the 9th, u to the 3rd, w to the 4th, over v to the 5th. And there's your solution. Now, a good idea, like I said before, is to do this more than one way, maybe. Now, I'm pretty darn sure I'm right, but I'm going to go ahead and do it in my head a little bit more this time. So I have 8, oops, I need my pen. I have 8 9t's. I have 3 v's, 4, 5 v's in the denominator. I've got, I ignore that. I've got a w cubed, and one more makes w to the 4th. I've got a u to the -3, and these u's cancel each other out. So I've got a u to the 3rd in the numerator. And it looks like it's the same, yep. T raised to the 9th. And this is going to be a little bit problematic because it's going to be hard to play with these. Not sure how I'm going to get this to work. First of all, I'm going to get rid of this so I can see it better. See if I can get this. It's on the wrong, darn it. It's moving to the wrong location. Let me see what else I can do about this. I'm just going to try. I'm going to have parentheses to work with. Let me see if I can put it. Okay, I'm going to try one more time. T raised to the 9th. There it is. W raised to the 4th. You have to point at just the right location to get this to work. Okay, I'm going to put it in the denominator right now. V raised to the 5th, and then see if I can get it back up here. There it is. U raised to the 3rd, and I'm going to double check my work. Looks good. All right. The only hard part is putting it in, I think. All right, I'm going to do maybe one more. I've spent way too long on this already. All right. We have a y to the 9th. Hopefully you can see. You know what? I think I might do it. Hang on just a second. There. I have y to the 6th, z to the 3rd, y squared, z to the 0, y, and a z. Remember, these are ones, even though we don't usually see them. Now, I'm just going to add my exponents. Now, I want to have the y's first because they're alphabetical order. That's going to be 9, y to the 9th, and I have z to the 4th. And that's it. That z to the 0 doesn't count. Y to the 9th, z to the 4th, yeah. Oh. There it is. Okay, this is going to be, I don't know if you can see it okay. Hopefully you can see it all right. I'm not sure if it's big enough. I've got a p squared and a q to the 6th. I'm just simplifying my numerator. And I have a p squared and a q to the 8th in the denominator, which is 1 over q squared. And let me just double check it here. Yep, that's the one. The p's cancel each other out. Now, one of the things you want to keep in mind is that later on in mathematics, it's really important that when you cancel out things like this, you have to put in this little comment that p can never be equal to 0. Also q, of course, because q is in the denominator. So we would normally put p and q not equal to 0 because the p's have disappeared from the expression. We've simplified them out. And so there would be no way for anyone to know that the p was ever there at some point in the programming or in the problem or something. So it's important that you put that disclaimer in there. It's called a restriction, sometimes called a domain restriction for X. Anyway, something you have to keep in mind when you do upper level math. Looks good. All right, I think probably done enough of these. I've got an a to the -9, so I'm going to move it to the numerator. I'm also going to move my a squared to the numerator. I'm going to leave my b to the 24th in the denominator. What I'm doing is I'm just basically dealing with all the stuff in the denominator. Now in the numerator, I've got an a to the -1 and a b to the -1, which is just ab in the denominator. So I'm going to simplify some stuff out. This a simplifies with one of these, gives me a to the 10th over b to the 25th. And like I said, there's lots of ways to go. I'm just going to go ahead and use this one. A raised to the 10th over b raised to the 25th. And because I just want to double check my work, 24, 25, yeah. And 11 minus 1 is 10, yeah. I actually did the adding the exponents and subtracting the exponents in that particular case, as well as doing the movement. It's always good to do it a couple different ways just to check your answer. All right, lots of stuff going on here, but it's all in one line. A lot of adding and subtracting, well, adding exponents. So I've got an S, T, U, V. So I'm going to write S, T, U, V. And I'm going to add all the S's together. So I've got negative 41. I've got a fourth. And I've got a 72. And that's it for my S's. So when I add those together, I have 76 and negative 41, which is 35, I believe. That is 76. That is 35. Yeah. Now I'm going to do the T's. I've got a 4, a 98, which of course is 102, and a negative 1, which is 101. And now I'm going to do the U's. I've got a 3, 6, and a negative 45, which is a negative 39. So that's going to go in the denominator, isn't it? And that's a 101 in case you can't see it very well. And it looks like we have some V's here. I did that one already. 6, 7, 8. It's like V to the 8th. So I think I'm done. So I have S raised to the 35. Oh, got to do a fraction. Darn it. It's going to be a real problem. All right, that's enough. Almost 30 minutes worth. If you want to see more, I'll definitely do some more, but I think that's probably far enough for this one. So if you need some more examples, I'll certainly do some more and go all the way to mastery, or give you some of my own. I can make them more interesting, or you can send me one. So I'll see you back again. Bye.